65-gallon electric water heater with upper and lower 4,500 watt elements operating at 240 volts tripping the breaker every 4 to 6 months suggests a problem that needs to be systematically investigated. Currently, the heater is connected to a 20-amp Federal Pacific Electric double-pole breaker with number 12 American wire gauge wire. You are reading 18.3 amps per leg at the panel and 235 volts line to line at the heater. You are considering upgrading to a 30-amp circuit with number 10 wire. Here's a breakdown of potential causes, solutions, and considerations. Firstly, let's address the possible causes. High water demand could be the culprit. Check if there is an unusually high demand for hot water. This could be due to multiple appliances running simultaneously or a larger than usual family using a lot of hot water. Consider installing a larger water heater to meet the demand or try staggering hot water usage. A faulty breaker is another potential cause. Inspect the 20-amp breaker to ensure it is not faulty or malfunctioning. Breakers can weaken over time and trip prematurely. Replacing the breaker is a simple and inexpensive first step. Loose connections can also cause problems. Check all electrical connections at the heater, the panel, and along the wiring for any loose or corroded wires. Loose connections can create resistance, which generates heat and can trip the breaker. Tighten or replace any damaged connections. Scaling within the water heater is another possibility. Over time, mineral deposits can build up inside the water heater. This scaling reduces the heater's efficiency, causing it to draw more power and potentially trip the breaker. Flush the water heater regularly to remove scale. A defective thermostat could also be the reason. A faulty thermostat can cause the water heater to overheat. This overheating can cause it to draw excessive current and trip the breaker. If necessary, replace the thermostat. Secondly, let's explore solutions like upgrading to a 30-amp circuit. Switching to a 30-amp circuit with number 10 wire is a viable solution if the current circuit isn't sufficient. However, there are several things to consider. Ensure that the breaker in the panel is rated for 30 amps. Do not simply replace a 20-amp breaker with a 30-amp breaker without verifying that the wiring and other components are rated for it. Number 10 American wire gauge copper wire is required for a 30-amp circuit. The existing number 12 wire is not sufficient and must be replaced for safety. Install a 30-amp receptacle at the heater. This ensures that the heater is properly connected to the new circuit. Thirdly, there are additional considerations to keep in mind. Check if the water temperature is set too high. Lowering the temperature can reduce the power consumption of the water heater. Ensure the water heater is properly insulated to minimize heat loss. Proper insulation reduces the amount of energy needed to maintain the water temperature. Inspect the plumbing around the water heater for any leaks that could be wasting energy and contributing to the increased electrical demand. A small, unnoticed leak can waste a significant amount of hot water. Fourthly, let's look at further troubleshooting tips. Connect a wattmeter to the water heater to measure its actual power consumption. If it exceeds the rated wattage of 4,500 watts, there may be an electrical fault or other issue. Keep track of when the breaker trips and look for any patterns. For example, does it trip at specific times of the day or after certain activities that involve high hot water usage? Identifying patterns can help you pinpoint the cause. Keep in mind that Federal Pacific Electric (FPE) breakers have a history of not tripping properly. While you are getting 18.3 amps per leg, this reading may not be accurate as the breaker may be compromised and not functioning as expected. The age of the breaker, being installed in 2004, also adds to the potential likelihood of failure. Replacing the FPE breaker with a modern square D or 8-in breaker of the same amperage could prove a possible solution. If you are unable to resolve the issue yourself, contact a licensed electrician for professional assessment and repair. Working with electricity can be dangerous, so it is best to leave complex troubleshooting and repairs to a qualified professional. Now let's dive a little deeper into each of these potential issues. When addressing high water demand, consider the lifestyle of the residents. Are there teenagers who take long showers? Does the household frequently run the dishwasher and washing machine simultaneously? Implementing water conservation measures, such as low flow shower heads and faucet aerators, can help reduce hot water usage. Explain the benefits of staggered usage to the family. For example, running the dishwasher in the evening after peak shower times can reduce the load on the water heater. When inspecting a faulty breaker, visually examine it for any signs of damage, such as cracks or discoloration. Use a multimeter to test the breaker's continuity and ensure it trips properly when overloaded. If the breaker feels loose or does not snap firmly into the panel, it may be worn out and need a replacement. When checking for loose connections, turn off the power to the circuit at the main breaker panel before working on any electrical connections. Use a non-contact voltage tester to verify that the power is off. Carefully inspect each wire connection for corrosion, fraying, or damage. Use a torque screwdriver to tighten connections to the manufacturer's specified torque. This ensures a secure connection without over-tightening. To flush the water heater, first turn off the power to the heater at the breaker. Then turn off the cold water supply valve to the heater. Connect a garden hose to the drain valve at the bottom of the water heater and run the hose to a safe drainage area. Open the drain valve and let the water drain completely. Flush the tank with cold water until the water runs clear. Close the drain valve and refill the tank with cold water before turning the power back on. Regular flushing, typically once a year, can prevent scaling buildup. When replacing the thermostat, be sure to purchase a replacement thermostat that is compatible with your water heater model. Turn off the power to the heater before removing the old thermostat. Carefully disconnect the wires from the old thermostat and connect them to the new thermostat following the manufacturer's instructions. Ensure the thermostat is securely mounted in its proper location. When upgrading to a 30-amp circuit, it's essential to follow all applicable electrical codes and safety regulations. Obtain the necessary permits from your local building department before starting any electrical work. Use only approved electrical materials and equipment that are rated for the intended use. When running the new number 10 wire, ensure it is properly supported and protected throughout its entire length. Use conduit or cable staples to secure the wire to walls and ceilings. Do not run the wire through areas where it could be damaged or exposed to moisture. When installing the 30-amp receptacle, use a dedicated circuit for the water heater. Do not share the circuit with any other appliances or loads. Ensure the receptacle is properly grounded to prevent electrical shock hazards. When checking the water temperature setting, use a thermometer to verify the actual water temperature. A typical setting of 120 degrees Fahrenheit or 48.8 degrees Celsius is sufficient for most household needs and can help conserve energy. Avoid setting the temperature too high, as this can increase energy consumption and pose a scalding hazard. To improve the water heater's insulation, consider wrapping it with an insulating blanket. These blankets are readily available at most hardware stores and are easy to install. Ensure the blanket is properly fitted and does not block any vents or access panels. Insulating the hot water pipes can also help reduce heat loss. Use foam pipe insulation to wrap the hot water pipes that run from the water heater to the fixtures. When inspecting the plumbing for leaks, check all connections, fittings, and valves for any signs of moisture. Look for drips, puddles, or water stains. Tighten any loose connections or replace any damaged components. Even a small, slow leak can waste a significant amount of water and energy over time. When using a wattmeter to measure the water heater's power consumption, connect the wattmeter to the circuit breaker for the water heater. Turn on the water heater and let it run for a period of time. Record the wattmeter readings and compare them to the water heater's rated wattage. If the actual power consumption is significantly higher than the rated wattage, there may be an electrical problem or a faulty heating element. When monitoring breaker trips, keep a log of the date, time, and any relevant circumstances surrounding each trip. This information can help you identify patterns and potential causes. For example, if the breaker trips only when the dishwasher and washing machine are running simultaneously, it suggests that the circuit is overloaded. Remember that FPE breakers are known to have a high failure rate. Even if the breaker appears to be functioning normally, it may not be providing adequate protection against overloads and short circuits. Consider replacing the FPE breaker with a more reliable breaker from a reputable manufacturer. When calling a licensed electrician, be sure to provide them with all the information you have gathered about the problem. This will help them diagnose the issue more quickly and efficiently. Ask the electrician about their experience with water heater repairs and their credentials. Choose an electrician who is licensed, insured, and has a good reputation. In addition to these specific troubleshooting steps, there are some general safety precautions to keep in mind when working with electricity. Always turn off the power to the circuit before working on any electrical components. Use insulated tools and wear appropriate safety gear, such as rubber gloves and safety glasses. Never work on electrical systems in wet or damp conditions. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. By following these steps, you can systematically troubleshoot the problem and identify the cause of the breaker trips. Whether it's a simple fix like replacing a faulty breaker or a more complex issue like upgrading the electrical circuit, addressing the problem promptly will ensure the safety and efficiency of your water heater. Let's also clarify a few details regarding the electrical components. When discussing wire gauge, American wire gauge, also known as AWG, is a standardized wire gauge system used predominantly in the United States for the diameters of round, solid, non-ferrous, electrically conducting wire. The higher the gauge number, the smaller the wire. Therefore, number 12 wire is smaller than number 10 wire. The smaller the wire, the less current it can safely carry. The National Electrical Code, or NEC, specifies the allowable ampacities, or current carrying capacities, for different wire sizes and types. For copper wire, which is typically used to residential wiring, number 12 wire is generally rated for 20 amps, and number 10 wire is generally rated for 30 amps. However, these ampacities can vary depending on factors such as the insulation type, the ambient temperature, and the number of current-carrying conductors in a raceway or cable. When upgrading to a 30 amp circuit, it's essential to use the correct size wire to ensure the safety and reliability of the electrical system. Using undersized wire can cause the wire to overheat, which can lead to insulation damage, electrical fires, and other hazards. It is important to consult the NEC or a qualified electrician to determine the appropriate wire size for a specific application. Another important consideration is the type of circuit breaker used. Circuit breakers are designed to protect electrical circuits from overloads and short circuits. When the current in a circuit exceeds the breaker's rated amperage, the breaker will trip, interrupting the flow of electricity. There are different types of circuit breakers available, including standard thermomagnetic breakers, ground fault circuit interrupter, GFCI breakers, and arc fault circuit interrupter (AFSI) breakers. Standard thermomagnetic breakers are the most common type and are designed to protect against overloads and short circuits. GFCI breakers are designed to protect against ground faults, which occur when electricity flows through an unintended path, such as through a person's body. AFSI breakers are designed to protect against arc faults, which are dangerous electrical arcs that can cause fires. In the case of a water heater circuit, a standard thermomagnetic breaker is typically used. However, it's important to ensure that the breaker is properly sized for the circuit and that it is functioning correctly. As previously mentioned, FPE breakers have a history of not tripping reliably, which can pose a safety hazard. Replacing FPE breakers with more reliable breakers from a reputable manufacturer is highly recommended. Finally, let's discuss the importance of proper grounding. Grounding is an essential safety measure that provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock hazards. All electrical circuits and equipment should be properly grounded in accordance with the NEC. The grounding system typically consists of a grounding electrode, such as a ground rod or a metal water pipe, connected to the electrical panel with a grounding conductor. All metal enclosures and equipment are then connected to the grounding system with grounding wires. In the case of a water heater, the metal tank and the electrical connections should be properly grounded. This can be achieved by connecting a grounding wire from the water heater's metal enclosure to the grounding terminal in the electrical panel. Ensuring proper grounding is essential for protecting against electrical shock hazards and for ensuring the safe and reliable operation of the electrical system. In summary, troubleshooting a water heater that trips the breaker requires a systematic approach. Start by identifying potential causes such as high water demand, a faulty breaker, loose connections, scaling, or a defective thermostat. Then implement solutions such as upgrading to a 30-amp circuit, flushing the water heater, or replacing the thermostat. Finally, consider additional factors such as the water temperature setting, insulation, and plumbing leaks. By following these steps and consulting with a qualified electrician when needed, you can resolve the problem and ensure the safe and efficient operation of your water heater. Remember that electrical work can be dangerous, and it's always best to err on the side of caution. If you are not comfortable working with electricity, hire a qualified electrician to do the work for you. This ensures that the work is done safely and correctly, and that your electrical system is protected from damage and hazards.